can you think about something so that when you square it, you end up with -1? Because we want to end up with -1, so maybe we should use negative numbers, right? So maybe we can put down -1. But this is actually not correct, because if you square -1, that means you will have to do -1 times -1, and you end up with +1. That doesn't give you -1, so you can see that this right here is not correct. What other number can we use though? Remember, when we have a square, both numbers have to be the same. Well, the truth is, in order to solve this, we actually have to have imaginary solution, and that's the concept of I. Something square gives us -1. We are going to define I to be the imaginary unit so that I squared gives us -1, and that is just by definition. Cool. And in fact, there's another answer for it, and that's a negative version of it. Because if you square -I, that will be -I times -I. Negative times negative is positive. I times I is I squared. And again, by definition, we get -1. So in fact, we have both plus and also the negative version of I, and that will satisfy this equation. Okay, cool. But I think many of you guys have learned this before already, so I'm gonna just change this a little bit. Instead of talking about just numbers, we are going to have more numbers in like boxes or something, and that's called a matrix. So let's see. So instead of a -1 right here, I'm going to write it as -I, and the I is the identity matrix. And in this video, I just want to show you guys the 2x2 case. The identity matrix is just that you have like bracket with a bunch of numbers. Just think about it like that. For the identity though, we don't just put down like all ones inside. No, we just want to put down the ones on the diagonal and then 0 on the rest. And technically, I will write this down. Negative and the I means 1, 1, 0, 0. This is just a constant multiple. You can multiply this in, so you end up with -1, 0, 0, -1. Now the question for you guys is that, can you think about a 2x2 matrix that you put here, square that, you end up with -1, 0, 0, -1. Well, if you say the answer is I, 0, 0, I, you are correct. It works. Let me show you. This thing square means you do I, 0, 0, I times itself. And this is how we multiply two matrices. We will do the dot product of a row and a column. It means we do this times this plus this times that. So I'll write down I times I, and we add this times that, which is 0 times 0. And then we do the rest. This times this plus this times that. So I times 0 plus 0 times I. Continue. This times this, 0 times I plus I times 0. Finally, 0 times 0 plus I times I. And have a look. That is just I squared, which of course we know that's -1. And then this right here is just 0. Likewise, this is 0. And then this right here, we get -1 again. So as you can see, I, 0, 0, I works, just like what we had earlier. And the truth is, you can have both plus or minus here, or plus or minus here. So right here, you can get 4 solutions for this equation. But here is the truth for this. In fact, you have infinitely many solutions to fill in these parentheses for 2x2 matrix. And another truth is that you don't have to use imaginary number. Don't believe me? I will give you guys another example. Here, let me give you -3, 2, -5, and 3. It works. If you square that, this will give us -3, 2, -5, 3 times -3, 2, -5, and 3. And then we'll do what we did like this. So have a look. -3 times -3, and then we add 2 times -5. Continue, this times this, plus this times that. And then this times this, plus this times that. And finally, this times this, plus this times that. Now, ladies and gentlemen, that's 9 minus 10, that is 1. That's -6 plus 6, that is 0. This is positive 15 minus 15, that's 0. Sorry, 2 times -5 is -1. 2 times -5 is -10, plus 9 is -1. Lastly, that's -10 plus 9. We get -1. Aha, have a look. This is a 2x2 matrix where we didn't use any non-real numbers. They are all real entries. And when you square that, we end up with this right here. Very, very nice, huh? If you want to see how to find out all the solutions to solve this equation, you can check out my other video right here.